Good afternoon, everyone. Uh, I'm going to mainly discuss about what we understand about the digitization of subject matter expertise and what are our views, and they are largely coming because they are coming from Halliburton and we are mostly in the upstream business. That's where we are and how we see that it ties to the digital transformation. So the most important slide of my presentation, that whatever I say is on me, not on Halliburton. So the main thing is that today when I want to discuss with you, the few takeaways that I want to have is that you understand the challenges that we are going through right now. What and how the big data plays a role in as we move forward in upstream exploration and production. How we see domain knowledge and what is its importance, and in the E&P life cycle, where it exists, where it brings value, and how it transforms our business. And then I will share some of the applications which are tied to the domain knowledge extraction and what I meant by that. So since we had the downturn and we in a new reality where the oil prices are, I hope some of you have bought stocks in last 1 week or 1.5 weeks. And if not, then you know where we are. You know, that's cyclical nature of business, that's where we live. And because of that, there are different things that have changed in last 4-6 years. And one of them being that talent is one of the things, as Marty was saying, and as initially Mike was talking about, there's a crew change that is taking place because last 2 decades or so, there was a period where we did not hire very actively. And because of those gaps, now we see that we are now short on talent. Just from the data science perspective, I think that 3 years back, the report from McKinsey was that we need 250,000 data scientists in US, and I think now it has already gone to million. So you see that there's a lot of demand in these areas. As in oil and gas, we have inefficient workflows, but those are legacy, those are given, and this is how our world is. The other part is that important aspect is the cultural silos, which I believe, as far as I've seen, every industry is going through the same thing. So it is not abnormal for us to see that, but those are the things that makes it even more challenging when you have to run operations in a very optimized way. And then we are a little slower than rest of the industry in adopting the emerging technologies. As you see that on the west side of US, east side of US, the adoption of open source is much faster compared to us. And that is something that we are changing slowly and steadily because we believe that we need to catch up with the emerging technology to really extract value from the data. And the last part is that we call the dark data. And what is dark data? It is in my laptop, in your laptop, and in your colleague's laptop, which is not connected. Yet you are drilling $20 million well, $40 million well, and other than you, nobody really knows the real situation of that well. And that kind of dark data is much more valuable than anything to us. And connecting anything, because as I will share, we look at, we appraise, we drill, we complete, we produce. And if you think of in terms of a single well, a well is a well. So a lot of information which is tied to a single entity called well, you need to have all that information to make a complete picture, and that is sometimes it's missing. So the E&P digital transformation basically relies on asset intimacy. What that means is that for being competitive in our industry, that for every executive, us, competitors, operators, everybody has the same metrics. They want to look at the ROI, they want to focus on the lower cost per barrel of oil, reserve replacement ratio needs to go year over year. That's how you are being perceived in the market. And your HSE metrics, basically you have to run the safest operation that you can. Anything that is underneath, that's where the actual grunt work takes place. That's where almost all the effort goes into it. All the operation leaders, they think in terms of what is my exploration success, how I'm going to optimize my reservoirs, production, and how to reduce the cost and the risk. The actual value and the decision making that takes place is in this petroleum investment life cycle, where we are exploring, we are finding reserves, we are constructing well, we are producing, and then it's a continuous improvement process where you are continuously creating the information and you are sharing the information. But that's where the challenge is. Means the learning and the growth in the digital era is coming from the last part, where we have to be digitally engaged within the organization, with the customers. We need to be aligned on our business objectives. And it is a continuous improvement process because I have the data, I had the data, and I will have the data. So it is not something that I'm going to stop and I think that I have achieved those goals. So we need to continuously innovate as the data is coming, and it's more coming higher density data. We are putting more sensors more and more. And for that, to achieve those goals, change management, change in the mindset, paradigm change in the thought process, it is the most significant aspect of it. When we look at the digital transformation, there are four main aspects that we see. One, we are instrumenting field like anything, like we have not seen anything before. Every pump, every bit, every drill bit, every BHE assembly, we are trying to put sensors on it so that we can understand what is going on. We are a real time, we are an operation business. We want to make decisions in real time. So we do not make drilling decisions week after we have drilled. When we are drilling in 12 hours, we make decisions right over there at the location. Because of the first two steps, there is a huge amount of information that we are creating, and it needs to be aggregated somewhere, and that's where we see that the integration of the data and the aggregation, it needs to happen in cloud. Whether it's a public cloud, whether it's a on-premise cloud, that is a different thing, but that kind of entity will remain moving forward. But first three steps are the one where you are creating data, you are aggregating data, and you are storing it in some way of fashion. But last step is the one where we see the most value gets created. Either we have on the field we have edge analytics and we are making decisions based on that, but even those models are built back the data which is in office and they get deployed on the edge devices. So this is the most crucial and instrumental part in digital transformation, how to leverage the data, and data in what forms that we acquire in oil and gas. That is important because a lot of our data is historical and untapped, and in most of the time it may be free text and it may be analogs and it may be PDF. So every form of data type gets considered when we are looking at as the value extraction being the primary proposition as we move forward. So when we look at it, the digital transformation, it is, as Marty was discussing, his presentation was exactly what this slide talks about. You look at what you need to integrate, you need to look at what digital levers you need to solve a problem. You want to understand where your business is going to transform. Either it is how we are going to invest, either how we are going to operate or interact, or how our employee works. So everything that comes into it, but everything ties back into the business outcome. So it's not a scientific exercise. It is a tangible exercise that that has a tangible outcome. And the same thing happens backwards, where basically your management communicates with your operational leaders. And this two-way alignment is very important when we are looking at the digital transformation. But how do we see it? Means one way to see it, like, six blind guys describing an elephant, touching and feeling different part and saying that what is big data and what is an elephant. So over here, the analogy is elephant. And I think in last few years, what has happened, especially in oil and gas, a lot of definitions came along. Everyone came with their own perspective, and none of them are wrong, but everything is an element. That's what we see. But the discussions are so far and wide that it becomes really confusing to comprehend what is big data, what are the objectives around big data, and what are we trying to achieve over here. And what we have realized is that for us, it is about all the data that we are collecting, connecting the data for the problem that we want to solve. We don't want to boil the ocean. We want to be very pragmatic when we are solving a problem. So the problem in hand and the related data that we need to connect, that's what we want to solve. Yeah, we need flexibility, so we need cloud. We want it to be connected from anywhere. If I have team in Houston or in Brazil or in Middle East, they should be able to solve the same problem. Emerging technologies, as I was talking about it, but the most important aspect where the digital transformation is really focused is finding the hidden inefficiency in the system. And that's where we are very much focused, because being an operational company, we have to find out what we are not doing right, where we can improve our operational efficiency, where we can bring more value to the customer. So for us, big data is all about finding the inefficiencies and getting rid of them. So for us, the main tenets have been that look at all the data. Don't have if it's a HSC problem, look at device, look at the variables, look at the operator, look at the drilling logs, look at the rig logs, everything into it to understand what is our HSC metrics. If you leverage all the technology that is out there, don't be like, yeah, machine learning or not machine learning. If my problem is beyond machine learning, yes, I will use those algorithms, but I also use things that I need beyond that. So don't be close-minded. Just look at what is the right solution for my problem and then solve it. And main focus is on creating the actionable insight. Means we did the analytics. We said, okay, this is how we need to change how we run our crews. Now that is a given fact, and that explains that how we can save multi-million-dollar on our operation. But unless we have a system that takes those actionable insights and implement them back into the system, and basically which ties to the change management, those goals are not realized. Those insights are valuable, but they are not realized until we have this feedback loop where we are deploying those learnings in the field. And the aspect is that when we talk about hidden efficiencies, it can mean many things. One aspect is operational efficiency. Another aspect is looking at the softwares and the way we do workflows in our softwares. We are a 90-plus-year-old company. We have huge legacy software systems in our fold. And we jump from one software to another software to another software sometimes when we do our workflows. And they take time. And there is a lot of inefficiency that just go in input and output. So there are many forms of inefficiencies in the system, one being direct and other being indirect, and we are looking at every aspect of it. So what changes? Changes is the thought process, how we look at it, how we have looked the data, how we have looked at our operations, how we have looked at our own conventional way of doing things. So those things needs a mindset change that, yeah, I know how we have been doing drilling last 30 years, 40 years, 80 years, but can we improve? Is there a better way? Is there a way that we can do the same thing with lesser people? And you can use those people for a higher quality work rather than everyone doing the same thing. So those kind of ideas and those kind of thought process are needed when we are looking at digital transformation. And patterns from the data is going to be the paramount in every aspect that we are working on. But for us, main is stakeholder value. And stakeholder value is two things. One is the company itself, the business, and the other aspect is the customer, where they see the value in terms of how Halliburton brings value to them is another aspect of it in looking at it. Sometimes it's not just about our own data. The customers are giving their own data, said, help us, because you have the domain experience. And that comes to my another point is the domain expertise. Because all these tools are good, but integral part of it is the expertise that is needed to leverage that data. So if you look at the whole E&P life cycle, the first four part of it is where you see the main, technical disciplines which are divided. You will have geologists, geophysicists, reservoir and drilling engineers, and completion and production engineers. So these are different personas who have a different perspective how they look at the data. Geologists, geophysicists, and by background I am a geophysicist. We are exact in terms of the science. We look at abstract concept and we think in 3 dimensions. So those are the three important aspects, how we look at the data. Mostly engineers, they are more driven by numbers and they look at a one-dimensional aspect of the reservoir. So the personas and the way of thinking, and it is not today, it is how we as an industry are and our jobs are. This is how we think, and that's why the knowledge that we create is essentially very different. So if you look at on the left side, this is the geologist and geophysicist world. Means this is 3-dimensional. These are abstract concept, how the levees and, these are like levees which were formed maybe in Jurassic, 130 million years back. We go back and we look at them and then we create maps to identify where oil and gas is. These are the seismic sections where geophysics works largely, and there are each wiggle, that blue and red that you see over here, means each wiggle is twice the size of this room. So those are the worlds, those are the kind of data that we deal with and we try to understand, to make sense, to understand where is oil and gas. Whereas drilling engineers, they are on the right side, where they are looking at a particular well at that location and how the formation properties are changing in that location. So when we are looking at that, this is a huge amount of information that sits right now in an analog form. And when I say about it, this is some of the recently UK government started a project which basically they are providing all the documents, because they provide blocks and bidding takes place in offshore UK and offshore Norway. And all these documents that I showed you in the previous slide, they are in analog form. They are in paper form. They are saying, is there a way to convert that information into digital? And not only that, can we interpret them after converting them digital so that we can they can identify the potential areas where the payout zones are, net payout zones. So when you look at that, these are log images. Maybe I'm not sure if you can see from the back the quality, but these are log images, report images, all different kind of reports and the data. And if you look at the dominant part of it are the TIFF images. So these are OCRs and TIFF images which are in analog form, and there's a huge, huge value in them. And the other forms are PowerPoints, PDF reports, Word documents. And every interesting part is that when these images were created, they were created by someone who has run the tool in a hole. It came up, it was just a paper form, because 40 years back, everything was in paper. Now everything is into digital. So those papers now being saved, archived as images, and someone has to go back and capture that knowledge. So that huge amount of knowledge that sits in these kind of documents. So what we see as data science bring value in these kind of problems where we have to capture data from the analog data sources. There are three things that are important from the data science perspective for us. One, we are going to automate a lot of this stuff, automating the extraction of the data from these type of analog sources, converting them to digital, and automating using machine learning to do the automated interpretation. So we are going to, so that more time for geoscientists and engineers, they spend on actual interpreting the data, because that's their actual job, not loading the data, not making the mouse clicks and all those things. So do the much more where the high value work is in the process. Second is, there are workflows which are complex, going from one software to another software to another software. And as an industry, if I have done a particular workflow, and if it has fortunately turned into something where I'm able to find the oil, or I have found the oil with that workflow, hell, I'm not going to change that. Doesn't matter what. I'm going to stick to it till I am retiring. So we better come up with areas which are so valuable workflows, standardized, which have proven value, yet to make them simple so that you are not spending 3 months in creating that workflow. The third part is the step change. Step change when we are looking at is the smart application. Where basically if I am doing a reservoir static modeling and which takes me a month or half in a month, can I do it in a day? So that kind of scale we are looking at. When we do the acquisition, seismic acquisition, it usually takes us 6 months from acquisition to create a seismic volume where someone can interpret it for looking at the oil and gas signatures in the data. Now think of it that there's a huge investment that gets logged for that 6 months. Can I turn that 6 months into 1 month, into 1 week? There's a huge proposition for us in looking at how we write the smart application in the next generation. So the upside is huge, how we are going to leverage the big data and the machine learning techniques. So this is one example. This is how our life is. We start at this scale. We start at Earth scale, look at plate tectonics, look at depositional environment, look at geochemical data, geomorphological data. We look at the region, where then we make the bidding, we identify the area, we do the basin modeling, we try to understand the petroleum system. In the licensed area, we do the acquisition, we create the static reservoir model, then we get to the well level, and we do the production analysis, and we do the reservoir simulation. Now the thing is, doing this whole thing, how long it takes? Any guess? White guess. Yeah, around 2 years, if it's a green field, yeah. So now once you have invested the huge amount of money and you have logged that principle in that one area, now for us the challenge is, can we do it quickly? Can we do it faster? Because if we can even reduce it half, there's a huge, huge value for us in terms of how quickly we can get to the production. And we are all working, doesn't matter who in this value chain is, we are all working towards the same goal. Get to the production as fast as possible, as quickly as possible. So what we have done so far? So we have realized that there's a huge value in the public domain. We have looked at all the publications, all the research paper that has been published, all the geochemistry data that has been published, and we have one aspect of our business organization which basically mines this unstructured data and create earth models. Because at this scale, from the planet to pore, means this is an image of a Permian basin, it takes us easily 6 months to 8 months. And if you already have a pre-built earth model for every basin in the world, you are basically reducing that 6 months to 1 month, where you are only focused on understanding, interpreting, and finding what is my petroleum system and what is the maturity. So then this is the kind of unstructured data mining and the knowledge capture that we are working on to get from the unstructured data. Because these things, once we do the extraction from the public sources, still geologists spend a lot of time in creating this global earth model. So there is one part is the automated extraction of that information from the data sources. Second part is taking that data, put a context to that, and turning it into something meaningful and tangible. And this is where we see that big data for us, it becomes a huge value. So what we are really looking at, we are capturing all kind of data that is applicable for a particular basin. We want to maximize the value of interpretation. We can create this from the public source, public domain data, and then we integrate your proprietary or customer's proprietary information with this model. Then you are suddenly enriching your model and you are getting multiplication of understanding on that particular basin. So this is one example that I wanted to share with you. This is from Northwest, Australia, and this is a 3-dimensional seismic volume. What what usually happens is that it takes, tools to interpret the faults which are structural discontinuity in the subsurface. And the desire is, can we turn that 2 months of work into a day work, into a 5-day work? And what it is over here is just not picking that structured discontinuities, but the knowledge of an interpreter. When they draw lines on the seismic section, basically it is through their knowledge of the depositional system. If you look at it, these are lines which are along the seismic section, what we call them faults. And you will see them all across this section, there are faults. But every fault has a characteristic in terms of what is the diagenesis of the subsurface. What kind of tectonic regime and the stretch regime exists to understand, is there petroleum over there? So for that, usually we do the fault interpretation, and on the right side what you see is the data, faults basically labeled by an expert. And what I'm going to share you with, on the left we have the original seismic data, and on the right side it is a machine learning based optimization method, which we basically, this is the first iteration that you see is a random initiation of that optimization. And as the iteration starts using machine learning, we find that the algorithm can work as good as an interpreter has worked, with less than 5% difference on the exact amplitudes on this. So here we see a potential of we are turning into a month-old work into like a day work, using cloud in parallel, but yet it is realizable. So we are looking at how we can really change the way we work. We are challenging ourselves the way we interpret using machine learning, but at the same time, it's not about replacing an interpreter. It is about augmenting the interpreter, giving them the tools and the power for them to work better and faster. So our goal is more to empower them rather than to replace them, and that is one of the myths that keeps on coming up, that machine learning is going to replace human. It's not happening. For us, it's not happening because risks are too high for us. Now, this is another example where it is about the unstructured document. So what happens is when we drill a well at that well location, every day there is a drilling log. It's a report, and it has engineering parameters on the top, and the bottom there's a box which a driller fills in that what happened that particular day. And what happens over here is that we were given 302 wells, which more than 9,000 daily drilling reports, which were PDFs. It is not digital data. And we were asked what information can we really get out of that kind of unstructured data, and what value it is to a particular company. So what we came up with is a classification scheme. It's called looking at the non-productive time. And we came up with, because in our industry, there is no standard definition for non-productive time. So it was divided into symptom, event, and action. Symptom being like your car. It shows up a sensor when you have to change the oil. You don't change it, one day it will break on the highway, and then you take it to the shop. So same thing, symptom, an event will happen, and then you will make corrective actions, and that is your non-productive time. So what you see over is the distribution of so out of these 302 wells, these were the top 20 wells where the operator was spending most of their investment. And these were the most problematic wells. And this is all we could figure out from these drilling reports using natural language processing and deep learning, no input really from the operator. But the even interesting part was this profile where it was every drilling report has a time stamp on it. So we did a time sequence analysis, and what you see is every company who has ever worked on that rig for the given, within the time frame the reports were given us, this is their quality profile. You see the symptoms, red is the event and blue is the corrective action. So every company who has worked on that rig, basically an operator can look at them and see that who brings more value for the money they spend on that particular operation. So basically it's a qualitative index for all the service providers on that particular rig. And at the same time, it also gives them an HSC metrics, a new kind of it that they never realized from it. So these patterns are are in the data, and what we are focused on really for leveraging them and creating value for ourselves and for customers. Now, there is only one thing, that last thing I would like to talk is the value-driven exercise that analytics is. So what happens is that when we are working, either it's our business or customer, we are at a point of time where the first question that is asked is why? Why do I need to do analytics? What it brings to me? And the first part is that as an analytics team, we have to take initiative to initially collaborate with them very closely to show them value in short sprints. You cannot have a 6-month project or a 12-month project. You have to do really fast fill methodology in 6 weeks to 8 weeks to prove that there is tangible value in the data that you are collecting. And you take one particular business objective and you show them there is a solution in that. And once that is done, then there is a natural progression that takes place, where then business is interested in exploring more and more and more, because now it makes them more efficient. Now it brings another value proposition when they are going in front of customer. And now they are looking at their business from the continuous improvement perspective. So there's a huge engagement exercise, and the responsibility largely goes on to the big data analytics team, because you are the one who are going to engage the business to help them understand what is the value in the data, not the other way around. And if that engagement is not there, they are not partners, then usually this exercise is very unproductive, and there is no value that really comes out of it. So the main thing is that there is a significant amount of information that exists in the analog data, and there is a huge potential to extract them. And it's just having in a digital format is not enough. Point is that even if we convert those logs into digital format, someone has to interpret them. So we have to take that last legwork of extracting them and doing an automated interpretation on it. So creating insight from that data is more important. So even if we have given someone a digital format that, this is your data in digital format, he's going to say, so what? So we have to help them in create value from the data that we are turning from one format to another. It's a really collaborative exercise. And what we don't have, and this is another topic which is close to my heart, is information and user provenance. What information sits where, what interpreter or drilling engineer did what workflow. There is the same two interpreters, same two drilling engineer can use the same software, yet their output is going to be same, but the process through which they create that output are usually not the same. So the workflow standardization, we are in 90 plus countries, we are more than 65,000 as a company, and one of our objective is the service quality. So the value that we give in North America to customers, if I'm in Siberia, I need to give the same quality of output to our customers. So for that, the workflow standardization needs user provenance, and this is another potential area that we see that there's a potential to grow, means as a solutions, which we have not seen that many yet. And the main thing is that converting domain knowledge to actionable items, that is what it is all about for us, especially from the digital transformation perspective. And thanks for listening.